Hey guys, what's going on? Today we're going to talk about distance between points and area and perimeter on a coordinate plane. So let's get started right now. If we're looking at the screen, I have a couple coordinates already put on the coordinate plane. So if we notice, we have A, B, and C located on this particular coordinate plane. So if we want to find the distance between points, we usually find two different options. We find the distance between points on the horizontal axis, or we find the distance between points on the vertical axis. So let's take a look and let's jump right in. So if we're looking at point A, we have the coordinates of 3, 3. So right now we're going to find the distance between A and B. So we want to go from A to B. Now we can simply just count them and say, all right, if I start at A, then I have 1, 2, 3, 4, 5, 6, 7 units. But what if I don't have the coordinate plane? If I don't have the coordinate plane, then I have to use the coordinates themselves. So I'll need the coordinates of B. So I'm going to put the coordinates of B, and we have the coordinates of -4, 3. Now, if I want the distance between 2 points that are horizontal from each other, which is the case between A and B, then I'm going to use the x coordinates only. And the reason why we do that is because the y's are the exact same number. So I'm just going to subtract 3 minus -4. And I have to use my rules for subtracting integers. So really what I'm doing is keep, change, which becomes 3 plus 4, which comes out to 7. The same thing as if we counted on the grid. So let's take the other look at from A to C. So let's get rid of some of this, and let's look at coordinate C. So now I want to go from A to C. Now A to C is vertical. So let's see how that's different. So if I put the coordinates for C now, I have 3, -2. Notice that the x coordinates are the same, but the y coordinates are different. So we're going to use the ones that are different. We're going to use the y coordinates. The x ones we don't use because they're the exact same number. So I take the y coordinates and I do 3 minus -2. And again, I say keep, change. So it's really 3 plus 2, and we have a distance of 5. If I go back to my coordinate plane, I can see 1, 2, 3, 4, 5. It comes out to 5. So we have a slight difference in how we use the coordinates if it's a horizontal distance or a vertical distance from each other. So let's go back to our distance between points and say that if the distances are vertical, so if it's a vertical distance, meaning up and down from each other, then we subtract the y coordinates. If it's a horizontal distance, then we subtract the x coordinates. So that's the distance between points on a coordinate plane. We can either count them easily on the grid, or we can use the coordinates themselves to get the distance without the grid. So now let's take a look at some area and perimeter problems. Okay. So let's clean this up a little bit so we have some stuff to work with. Okay. So let's first look at a rectangle. So if we have a rectangle, I'm going to draw some points of a rectangle on the grid. We'll call that A, B, C, and D. Now if we want area of a rectangle, we need the length times the width. Well, we can count the coordinates from A to B. We can say there's 3. And then from B to C, we can say that there's 1, 2, 3, 4, 5. So our area is just simply 3 times 5, which is 15 units squared. Remember, rectangle, we should have 4 measurements if we're doing perimeter. So if we wanted the perimeter, we just add all the sides. So we can say 3 plus 3 plus 5 plus 5. In this case, that would come out to 16 units. So if we wanted a square, it would be similar to the rectangle. So let's talk about a triangle. Well, earlier in the year, we did triangles on a coordinate plane or a grid, so we're going to have to go back to our knowledge of triangles. So I'm going to put points of a right triangle. So we have to have 3 points. And now we have a right triangle. So remember, our area for triangle is base times height divided by 2, or 1/2 the base times the height. We can use either formula. So let's check out our triangle here. So we need a base and we need a height. We have to remember that the base makes a right angle with the height. So if I'm looking at this particular triangle, we can notice that we have a right angle right in this corner, which then we can quickly identify the base and the height. So if I call this A, B, and C, the distance between A and B would be 1, 2, 3, 4. The distance between A and C, 1, 2, 3, 4, 5, 6, 7, 8. And I plug them into my equation, and I say A equals 4 times 8 divided by 2, which is 32 divided by 2, which is 16 units squared. Now, what happens if there's a composite shape? Well, let's look at the composite, which means we have multiple shapes combined together. So let's draw a figure here on the screen. So say we have some irregular shape here, which we're going to make a composite shape out of. So if you remember back earlier in the year, we said if we have an irregular shape, we look to decompose it into shapes that we are familiar with. Now, that can look different depending on your point of view. But if I'm looking at this particular figure, I see maybe I can cut this right here, and that way I form a rectangle and a triangle. So I'm going to use those two shapes now to get my combined area. So if I look at the rectangle I created, I can see that one of the sides, I'm going to have a length of 1, 2, 3, 4, 5, 6. And then if I go up to here and here, I have 1, 2, 3, 4. So my rectangle is 24 units square. Now if I look at the triangle, I have to remember the base and height have to form a right angle with each other, which means in this case it's going to be right here. So my base is just the opposite side of the rectangle. So my base is 6. And my height, if I start here, and I go 1, 2, 3, 4, 5. So I have a height of 5. And now I plug that into my base times height divided by 2. 30 divided by 2. I have 15 units squared. But I want the combined area, so I have to combine the 15 units squared plus my rectangle, which came out to 24 units squared. And that comes out to 39 units squared for the combined area. And we can have many different types of irregular shapes, but remember, we want to decompose them into shapes that we can find the area of, such as triangles, rectangles, squares. Now we can also have parallelograms, which we also covered, or even trapezoids. But again, we look to decompose them into triangles, rectangles, and squares. Thanks for watching, guys.